Okay, let's do tutorial number 6. Let's undistribute. All right, so undistribute, what does that mean? Well, we've been spending the last week or so distributing. In fact, we've been distributing since middle school, right? And so what we're going to be doing today is undistributing. Another way to say that, which most people do, is we're going to be working on factoring out a GCF. So let's look at number 1. We've got 8x minus 10. We want to change the form, make it look a little bit different without changing the fact that this really is 8x minus 10. So here we go. What does GCF mean? Remember back in the day, GCF means greatest common factor. So if we looked at a number like the 8 that we see here, we would say, all right, what are all the factors of 8? Which means factors are numbers that go in evenly into 8. Well, 1 is always going to be one of the factors, right? And how about 2 and 4 and 8 itself? So these numbers, 1, 2, 4, and 8, are the factors of 8. And let's do the same thing for 10. If we looked at 10, and we thought about the factors of 10, we'd see we have 1, 2, 5, and 10. So when we compare the factors of 10 with the factors of 8, what we're looking for is the greatest common factor. So what number do you see that's in common? Sure, they both have a 1, right? But the greatest number that they have in common is a 2. So 2 is called the GCF of 8 and 10. And that's what we're going to factor out. We're going to undistribute that 2. So we're going to take the 2 out, and we're going to see what we have left. So I'm going to stop here for a second because there's an intuitive way to do this, and then there's a very formal way to do it. And let me show you the formal way first so that you've got that down, and then we'll talk about the intuitive way. All right, let's stop for just a second and go into a totally different problem. Like, let's say we had 3 times 4x plus 4. And we would know, oh, we distribute, we're multiplying, right? 3 times 4x is 12x. 3 times 4 is 12. I don't know why I made them both 4s, but you get it. My whole point here is that when we distribute, we multiply. So what do you think we're going to do when we undistribute? That's right, we're going to do the opposite. We're going to divide. And so what we're going to do is we're going to look at this 8x, and we say, all right, 8x divided by 2. Well, that gives us 4x. When we could look at this as a negative 10 or just a minus 10. Either way, I'm going to bring down that minus sign. If we take the 2 and divide it by 2, if we take the 10 and divide it by 2, it's 5. And so here, this form right here is called the factored form of 8x minus 10. Now, we can double check our work, right? We can go ahead and distribute and make sure we get back to our original answer. So 2 times 4x is 8x. 2 times negative 5 is negative 10. Voila. We got right back to our original problem, and so we know that we did it right. So let's just take that away just for a second. I want you to notice something. 8x minus 10 is the same, has the same value as 2 times 4x minus 5. It's the second one, the 2 times the quantity 4x minus 5, is just another way to write it. And we are spending the time doing this. You got to trust me here. We're spending the time doing this, writing it in factored form, because we can do a lot more with a factored form than we can with the original form. All right, now I told you we were going to do it a formal way, and we're going to do it an intuitive way, more an informal way. So here we go. Let's get rid of all the stuff, and let's do the same problem again. We can just think, hey, what's the biggest number that goes into 8 and 10? That's right, 2. We're going to factor that out, and then we can say to ourselves, all right, I know I need a number here and a number here. I know that I need to distribute to get back to 8x. So 2 times what is going to give me 8x? Oh, 2 times 4x. 2 times what is going to give me negative 10? Oh, negative 5. So there we go. That's a second way to do it. But a lot of people, some people like the formal way, or just knowing that there is a formal way that they can always turn to. All right, let's try this intuitively. Problem number 2, we're going to look at 4 and 12. I want you to think, what's the biggest number that goes into both 4 and 12? You got it. It's 2 again, right? Is 2 going to always be our answer? I don't know. Well, you'll have to wait and see. All right, when we factor out a 2, we're saying to ourselves either 4x divided by 2 is 2x, or we're saying 2 times what is going to give me back to 4x. Same thing here. We could put the minus down. We could 12 divided by 2 is 6, or we could say 2 times what's going to give me negative 12. So 2 methods, we'll get the same answer. What we did again is we factored out the GCF, the greatest common factor, and now the expression 4x minus 12 is written in factored form. All right, let's see what else we've got here. Oh, now we're going to deal with numbers and variables. So we're going to first look at the numbers 6 and 2. What's the biggest number that goes into both of those? You're right, it's 2 again. All right, well, hopefully the next one, well, we'll see. The next one's not looking too promising either. I hope that I didn't make all these problems where just 2 is what we're factoring out. All right, but now we need to look at the variable. So I'm going to look at x squared and x. I'm going to remind myself that x squared is x times x, and of course x is just x. All right, what's the biggest amount of x's I can pull out that they both have in common? That's right, I can only pull out one x, right? Because if I pulled out x squared, it's like, oh, I don't have that to pull out there. So I'm going to factor out a 2x, and I have a choice. I can do it intuitively. I can say to myself, you know, who knows, 2x times 3x is going to give me 6x squared, and 2x times, ooh, this one's tricky, 2x times negative 1 is going to give me back to negative 2x. Or I can do it formally. And so formally says 6x squared, whatever we factor out, remember when we distribute, we're multiplying, but when we factor out, we're doing the opposite. We're dividing because we are undistributing. All right, so 6x squared divided by 2x, that's going to give me a 3x. So that's where that 3x came from. And when I take the negative 2x and I divide it by the 2x we're factoring out, well, look what happens. The x's cancel out, the 2's cancel out. What's left when everything cancels out? Now, some people will say 0, and I'm like, no! Even some of my pre-calc kids will say 0. No! Let's go back and think about it. What's 5 over 5, okay? 5 goes into 5 one time. We know 5 over 5 is 1, but yet we also know 5 over 5 cancels out. So now, when I ask the question, what number is left when everything cancels out? You're right, it's 1, but oh, there's that negative there. So that's why we get negative 1 right there. So either way, you don't get any extra points for doing this intuitively. You can do it the formal way and make sure that you get it right. All right, let's look at number 4. The first thing we're going to do is we're going to pick a good color. Haha, you didn't think I was going to say that, did you? All right, so we've got orange. I want to look at 8, 18, and 10, and I want to pick the biggest number that goes into all 3 of them. You know what it is, don't you? It's 2 again. All right. I think, though, there are good times ahead where it's not going to be 2. So we'll pull out the 2 because, right, the factors of 8 are 1, 2, 4, and 8. And we know that 4 doesn't go into 18 and 4 doesn't go into 10. And so the biggest number is going to be 2. All right, now let's look at the x's. We know that x cubed is x times x times x, and x squared is x times x, and x is just x. So we're looking for the largest amount of x's that they all have in common. And gosh darn it, it's just going to be that 1x, right? That's the only thing we can factor out, because if we can't factor out more than 1x because this guy doesn't have more than 1x to give. All right, so we're going to factor out the 2x, and we're going to do it intuitively first. And we're going to say to ourselves, 2x times what gives me back to 8x cubed? Well, that's 4x squared. 2x times what gives me back to negative 18x squared? That's negative 9x. And 2x times what gives me back to 10x? That's a positive 5. Or real quickly, we can switch gears and we could do 8x cubed divided by 2x. 8 divided by 2 is 4. X cubed over x, well, that's x times x times x, right? Only one x cancels out. There's 2 left over. That's x squared. So you get that the long way might take a little bit longer, but you can do it that way. But I'm going to skip because life is short and I want this video to be even shorter. Let's find a good color like, how about hot pink? That looks kind of like magenta. Let's see that. All right, so here we go. Let's look at the numbers for number 5. We're looking at 5, 15, and 10. What's the biggest number that goes into all of them? So once again, I'm using more street terms. Biggest term is not really a street term. But the formal way to talk about this is the greatest common factor. And so we're looking for the greatest common factor. And yep, by the time I've been talking, you figured it out already. Thank you very much. It is 5. All right, so let's look at the x's. What's the biggest amount of x's all three terms have to give? And you've understood, I think you guys have picked up, even though I don't see you through this video, or do I? I think you guys have picked up that we're always going to look at the smallest x cubed. I'm sorry, the smallest x that all the different terms have. And so x cubed is the smallest. That is going to be the largest amount of x's that all three of them can give. All right, so here we go. We're going to say 5x cubed times what is going to give me 5x to the 7th. Well, we know that we already have the 5, so we just need x to the 4th. Does that make sense? 5x cubed times x to the 4th is 5x to the 7th. Okay. 5x cubed times what is going to give me negative 15x to the 4th? Well, 5 times negative 3 will give me the negative 15. X cubed times x will give me the x to the 4th. Now, it's interesting because we've got coming up, we've got the exponential rules, which is going to help you to do this way, the formal way a little bit easier. But I think intuitively we're going to be okay here. 5 times negative 3 is negative 15. X cubed times x is x to the 4th. All right. 5 times what gives me 10? 5 times 2. And, x cubed times what gives me x cubed? Well, I just stopped there, right? Because if I were to distribute, let's switch. If I were to distribute, 5x cubed times 2 is going to give me back to my 10x cubed. So once again, we're taking an expression, we're factoring out the GCF to get it in factored form. All right, let's look at this next one. Let's look at the numbers. 5, negative 15, and 10. What's the biggest number you can factor out? Drum roll, and that's a 5. All right, what's the biggest amount of x's that all three terms have to give? That's right, we're going to look at the smallest amount of x's, and that's the x cubed. And I think by now, hopefully, the intuitive way is making sense. 5x cubed times what is going to get me back to the 5x to the 7th? Well, if we had an x to the 4th here, right? X cubed times x to the 4th is x to the 7th. 5x cubed times what gets me back to the negative 15x to the 4th? How about a negative 3x? 5x cubed times what gets me back to the 10x cubed? You'll notice that when this is the same as this, well, we only need to take care of the number, right? Because 5x cubed times 10 is going to give me the 10x cubed. All right, that's really the lesson. We do have a little bit more to do, but that's about once we factor and we're in a fraction, what can we do to simplify? All right, so let's look at number 1. We're going to first take care of the numerator. If I look at the numerator, we're going to be so good at this already. We've done so many problems. We're going to factor out the GCF, which is, yep, we're back to the GCF being 2. All right, what's left when I factor out the GCF? I've got an x here, right? Because 2x divided by 2 boop, gives me an x, and 16 divided by 2 gives me an 8. Now, look now where we're adding another step here. All right, so we have factored out the GCF in the numerator, and we are checking all the time. Now we've got a denominator to deal with. All right, so I want to stop right now, and hopefully you're listening to me, not just watching, because this next part won't make sense. I want to stop and go to baby math. All right, wonder if we had 2 times 3 over 2. Can you guys quickly do the answer, figure that out? 2 times 3 is 6. 6 divided by 2 is 3, right? We already know it's going to be 3. Would it make sense to you then that it would be okay to cancel out the 2's? Yep, we are allowed to do that, right? Now, if it were 2 plus 3 over 2, could we cancel out the 2's then? Absolutely not. We're only allowed to cancel in the numerator and the denominator if what we're canceling is being multiplied by what's next to it. So in this case, now let me use parentheses instead of a dot. So let's go back and use the same thing. 2 times 3 over 2. We already know the answer is 2. And so see how the 2 in the parentheses, that means multiplication, right? And so when two numbers are being, or two quantities are next to each other and being multiplied, we can cancel out with something in the denominator. All right, Whew, lots of rules. Practice is going to help us. So here we go. I'm going to say, oh, we've got 2 times the whole quantity x plus 8. I'm allowed to do this. Boop. And my answer is x plus 8. So simplify means take something like 2x plus 16 over 2 and simplify it down, right? Doesn't that look more simple? Is that a word, more simple? Doesn't that look less complicated? All right, let's do the same thing. And then let's stop critiquing my grammar. Let's just look at the numerator first. What can we factor out? We know we can factor out our GCF for our number is going to be 5, right? And then look at the x's. What's the biggest amount of x's we have to give, or both terms have to give? Just the plain old x. And so let's intuitively say 5x times what gives me 10x squared. I need a 2x, or 10x squared divided by 5, right? 2x squared. I'm sorry, 2x, because I was going 5x. Boop, boop, boop. Okay, 2x. And then 5x times what is going to give me negative 5x. This is actually where doing it the long way will make the most sense. Everything cancels out. I've got the negative, and I know when everything cancels out, what do I write? That's right, I write a 1. All right, all over 5x. I have the same dynamic here where I have 5x times, that parenthesis means times. I'm allowed to cancel out that 5x with the 5x, and I am left with 2x minus 1. All right, let's do it a couple more times. All right, for number 3, we're going to go ahead and we're going to factor. Oh, man, I didn't change the color. Bad on me. Let's go with this purple. All right, let's look at the numerator and let's factor out the GCF for the numbers. Oh my gosh, it's going to be a different answer than 2 or 5, right? 6, 9, and 12. What's the biggest number that goes into all 3 of those? What's our GCF? That's right, a 3. And now let's look at the x's. What's the biggest amount of x's that all 3 terms have? And yes, it's x squared. All right, let's see what's left. 3x squared times what? It's going to give me 6x to the 4th, 2x squared. 3x squared times what? It's going to give me back to negative 9x cubed, negative 3x. 3x squared times what? It's going to give me back to 12x squared, just a 4. So remember, when what we factored out is the same as the variable at the very end, we just need to write a number because 3x squared times 4 is gets us back to 12x squared. All right, and yep, you know this trick. When in the numerator, when we have something, so we have 3x squared times all of this stuff in the parentheses. When that happens, I am allowed to say 3x squared, cancel that with 3x squared. And what do I have left? I have the 2x squared minus 3x plus 4. So if you look at our original problem, we really did a good job, didn't we? We simplified it. We made it less complicated looking. All right, one more. Woo! 4, 16, and 36. What's the biggest number I can factor out? What's my GCF? 4, right? 4 goes into all of them. So let's look at our variables with the largest amount of x's that we can pull out that all 3 terms have. Yeah, just that plain old x, right? That's okay. We'll work with it. So 4x times x to the 3rd is going to give me 4x to the 4th. 4x times 4x is going to give me 16x squared, and 4x times negative 9 is going to give me negative 36x. And so once again, when we undistribute, we are really kind of playing a game of, hey, what do I need to put in here and here and here so that when I do distribute, I end up right back with my numerator. All right, let's undo what I just did because that's just making it look complicated, isn't it? All right, in my denominator I have 4x, and yep, we know the deal. The 4x's cancel out, and we have x cubed plus 4x minus 9. All right, this was fun. I hope it made sense. If not, ask me in class. Make sure that you do a good job with the practice and checking your answers, and thanks for joining me.